Thank you for joining this session. My name is Chunlei Chang. I'm a PhD student from National University. And our paper aims to evaluate perceptually complementary views for network exploration tasks. In the last 4 years, we have been working with a major bank in Australia to visualize their financial data. Our project is to visualize their event sequence data, one project. And this is 6 months sample flow data. And that's different accounts moving between different types of products. And they are changing their status with respect of activities with the bank. And for the small event sequence data, Sankey can be a very good way to visualize, to get a sense of temporal event flow. And there are 6 months data shown, and each column represents a month, and each node represents one product type. And the highlighted curved area represents flow or the links from one node to another. And its bandwidth reflects the value of the link. Sankey is very intuitive and easily understood. And however, if the data set gets larger and more complex, Sankey suffered from edge crossing issue and became overcluttered easily. Well, Sankey suffered from visual clutter from large data sets. A recent work, MatrixWave, done by Chang, effectively solved this problem. MatrixWave used a stacked sequence of the adjacency matrix in a zigzag tiling. And each square represents the matrix, one matrix, and it's shared the axis with the next matrix. And the matrix layout dedicates a predefined space for each link to be shown, so it won't get cluttered. The axis reflects the columns of the Sankey, and each cell represents a link in the Sankey. We showed MatrixWave to our domain expert in the bank, and they liked the design very much, but they said it's less intuitive and they are less familiar with them. So most of the users in the bank take a long time to learn how to master MatrixWave. So all those pros and cons of individual views actually inspired us to consider the effect of perceptually complementary view. For example, side-by-side with full interactions enabled. In this paper, we conducted 2 controlled studies to evaluate such combined views. There are a handful of experiments comparing node link and matrix representations. GoName evaluated different tasks for unweighted graphs. They found that for dense network, tasks were more easily completed with matrix. And Alper found matrix greatly outperform the node link for the edge weight comparisons. Both studies tested 2 representations in isolation, not side by side. From previous studies, we know that matrix seems to do better at showing edge weights. But for the sparse graphs, people can follow paths more easily in the node link diagrams. Given the node link and MatrixWave each have its advantage and disadvantage, we would like to study whether people can use them effectively side by side. We introduced and focused on a term, perceptually complementary, which is different views using different visual variables to show the same information, but with different representations. A good example is Matrix Explorer, a system proposed by Henry and Foucault with compelling scenarios. But such perceptually complementary views has not been formally evaluated. So we considered perceptually complementary views in 2 scenarios. We studied node link and matrices for weighted graph, and we studied MatrixWave and Sankey for event sequence data. The combined views offer full brushing and linking interactions. And if you hover over on the any element on one view, and it will highlight its counterpart elements in the other view. And potentially, the combined views allows the user to choose which, like the most appropriate views for the subtask at hand. and allow them to switch smoothly between different views without losing their mental model. It may also help novice users to learn unfamiliar representations from the familiar and the intuitive representations. Because each view has its pros and cons, so we wanted to understand that which tasks are better for which views in both scenarios. And also, we want to understand, do complementary views actually improve the performance, or it's merely just a distraction to people? And its complementary view effects was to add additional complexity. So another thing we want to understand is how do users to use complementary views? Do users understand which view or when to use which view in the combined views? So we record all their eye contact and attention span using eye tracker. Let's take a look one user's eye tracking recording for a trial. So this user used both views to solve the question, but he stick to node link view first, then switching to matrix view to double check. So before we started evaluation on complementary views, we found another research gap. There are many popular encoding methods in matrix, but no study to tell that which encoding method is the best for adjacency matrix. So we did a pre-study to figure out the best encoding for weighted edges. We selected 5 most popular encodings. Circle, square, and bar are using radius or length to represent its values, and opacity and hedge, both using the level of darkness to present values. We also applied the 3 new techniques. We also applied the fat fonts techniques and we created 2 new encoding methods. Fat fonts was proposed by Nascenta for tabular data, but it has not been used previously for the weighted networks. So it double encoding the values by its numerical value and the thickness and the size of the ink area. Background transparency is a combination of square and opacity. And we proposed another variation that using white background to provide better contrast. So in total, we evaluated 8 encoding methods. And we have 2 levels of tasks. The first task is detailed level to compare the thumb wedges for edges in the red and blue. And the second one is overview task to compare the value of dense areas in the red and blue. We didn't want people to calculate the sum of the weights precisely. So we removed the legend and training. We want them to use their visual impressions to make the decision. So we removed the legends after training, and we also imposed the 20 seconds time limits. We find that square and fat fonts are the overall better performance than other results. Details are on the paper. We found significant differences on both views, both encoding methods. We choose square as the encoding methods for the following studies because it's more likely to be more familiar representation for most of the people. So the second study, we evaluated the complementary views for node link and matrix. We have 3 techniques in study 2, node link itself, matrix itself, and their combined views. We have 2 hypotheses. The first hypothesis is that combined views to be more accurate for path following tasks, as participants would be find the possible path in the node link view, then they can verify their edges in the matrix view. The second hypothesis is that combined views will be at least as accurate as the best representations, as the best of the 2 individual views. So there are 4 tasks evaluated in the study. The first one is in the traffic network, find the cheapest road from red and to blue node. So we user need to compare the sum of edge weights. And the second task is that in a social network, find out which person have the most contact with other people. So user need to figure out which node have the most accumulated values. And the third task is find the cheapest road from red to blue node. This is similar to the first task, but with 3 hops in the roads. So user need to calculate all the possible nodes, possible roads. And the fourth task is triangle. We ask user to count how many triangles in the network. As you can probably see, for the path following tasks, it's very easy in node link, but it's quite difficult in the matrix. We recruited 29 participants in study 2. We asked them to complete the task as fast and as accurate as they can. So the y-axis is the error state, and the shorter the better for the accuracy. We found that no matter which view and which task, the combined views have the same accuracy with the best views. And in terms of completion time, we found that people sometimes take a bit longer time than the best single views, but it's definitely a lot faster than the worst single view. And this is eye tracking data for 4 tasks. X-axis represents 13 trials, and Y-axis represents percentage of visualization usage. So in the trainings, users spend equal time or even longer time to learn how to use both visualizations. But once they started the task, they tend to spend their time to stick to the best views. For example, the path following tasks, such as 3 hops or triangles, use most of their time on node link users use most of their time on node link in their combined views. So after we did a study on the weighted network, the third study we evaluated the complementary views on the MatrixWave and Sankey, which is event sequence data. Again, we have 3 techniques: matrix itself, MatrixWave itself, Sankey itself, and their combined views. We have same hypothesis that combined views will be at least as accurate as the best of 2 individual techniques. So in the first task, user need to figure out the most possible destinations of the floor. And the second task is to find out the largest floor of the graph. So this is a simple task that need to find out the largest value of the link. And the third task, users were given starting and ending node in the red and blue. And they need to follow and find out the most possible route in this task. And the last task is asking which nodes have the outflow and never return back to the node. Participants need to examine and follow through all the nodes to find out the answer. So this video shows that how users are using complementary views to solve the task 3. In the training task, users switch frequently between 2 views and find out the answers. So in study 3, we recruited 24 participants. For accuracy, combined views are the same with best performance in most tasks. In terms of completion time, combined views are faster than the worst performance, but slower than the best performance in all the tasks. Again, this is eye tracking data for 4 tasks. X-axis is the number of tasks, and the Y-axis is the percentage of the view use. Participants using Sankey in most path following tasks, but they're aware that MatrixWave can help them precisely read the edge values in task 2. So they spend a longer time on MatrixWave. Let's have a look at the summary findings for study 2 and 3 altogether. We found 3 common patterns of use through the eye tracking data. The x-axis is 20 seconds timeline, and the y-axis is the trial number. So the first one is exclusive use, which is through the entire 20 seconds. 56% users stick to one view only. And the sequence use is that some users use both views, but spending a long time on each views. And also we have users that is using parallel use, which is participants switching frequently between different views. Combined views, like other findings including combined views are overall no worse than the individual ones. So if you're thinking about it carefully, it actually makes sense that the performance is not superior than the individual views. But it's always close, or most cases it's same with the best single views, which means that people are able to find out the best views for each task. And some participants tend to stick with a preferred view across all tasks. Although the views is not the best views, but people still stick to it. And best participants were able to choose the best views for each task. So these are the overall findings for both studies. And now let's see if there is any questions.
Hi, Jeff Hare from University of Washington.
Hi.
I thought the use of eye tracking in the study was very nice, and I particularly liked the breakdown into the different strategies.
Yes.
And I was just curious if you could say something more about how those did or didn't correlate with performance. So for example, if someone's doing this parallel where their eyes are bouncing back and forth between these charts, is that actually an effective strategy, or is that just a sign that someone is having a hard time performing the task?
I think it really depends on task. If they switch very frequently, it means that they either go back and forth to double check, or it's they don't know which views to use. But those only 11% of users using switch very quickly back and forth.
On average, do they do worse or better?
We didn't look at carefully, but that's a very good point. Yeah, cool.
Hi, my name is Jan from MatrixWave.
Okay. Nice to meet you.
So my question is, every visualization is designed for a specific set of tasks. And Matrix is for one thing, one set of tasks, and NoLink is for another set of tasks.
Yep.
And you argue that you put them side by side, and people will be able to choose the best view and to perform a little bit better. Yep. But for network exploration, you have NoLink and Matrix, but for some other tasks, some visualization, high-level visualization tasks or data, you might have more than 2 views. And I wonder what's the generalizability for your results? And the second question is, do you have any ideas about suggesting the best view to the user?
Okay. For the first question, we actually have another definition. Let me get, which is informationally complementary, which is sort of like different views offers more information than any of its constitutes, like tabular data. Then it's all work together, so it's multiple coordinate views. But in this case, we only focus on exactly same information, but different representations. So we do have detailed analysis for each task, that under which task most user choose which views to solve the questions, and they have better performance. So yeah, But it's like overall 10 tasks. So suggest to read the paper and find out details.
Thank you.
Cool. Thank you.
So I think we're out of time for this talk.
All right.
Anyone has questions for any of the speakers, I encourage you to
All right.
afterwards.
Cool.
So, a round of applause.
Thank you.